Hi guys, it's Mrs. Millicent. Okay, in this video, we're going to look at how to trace recursive loops or recursive methods. Okay, this is the code that we just did in the last video. So we're going to trace our recursive countdown method and our recursive sum method. Okay, so let me zoom in on the recursive countdown. So what it's going to do is it's going to take a number and it's going to evaluate. Is it equal to -1? If it is, it's going to print blast off. If not, it's going to print that number with a space, and then it's going to run countdown of the next lowest number. Okay, so let's do a quick little trace here. We'll do kind of a low number so we're not writing forever. Okay, so let's say I want to do countdown R of 4. Okay, so let's count down from 4. So 4 does not equal -1, so it's going to ignore that. And what it's going to return is it's going to return num and a space, and then count down 3. Okay, so then we're going to have to do countdown 3. So it comes back here and runs 3. Again, it's not equal to -1, so it comes down here, and that yields a 3 with a space, and then it will run countdown 2. Okay, so it's going to keep calling itself. So we'll do countdown. Could have had a smaller method name, but whatever. It'll print the number, which is 2, with a space, and then countdown 1. And then we've got countdown recursive 1. So that'll equal 1 with a space of countdown 0. Okay, 0 is still not equal to -1. So now we have countdown of 0, which will equal 0, with a space of countdown R of -1. Okay, so now when we get down to our base case here, that equals -1. So what I'm going to get here is blast off. Okay, so now if we kind of go back up through the stack here, for this one, I'm going to get 0 with a space and then blast off because countdown of -1 is blast off. So I'm going to get 0, blast off. Okay, then I'm going to come up here and I'm going to get 1 with a space with all of countdown 0. Well, countdown of 0 equaled all that. So now I'm going to get 1, 0, blast off. Okay, so you can see the pattern. Then I come up here to countdown 2, so I'm going to get a 2, and then I'm going to get everything in countdown 1, which was all of this. 2, 1, 0, blast off, and then so forth. Countdown 3, I'm going to get 3, and then all of this. And then the last one, I'm going to get 4 plus countdown 3, which is all of that. And then I get the only thing that prints is this final leg of the recursive method, okay? So the system has to kind of hold all these values as it keeps building, okay? And then ultimately, I get my final outcome. That's what's actually outputted, okay? All right, now let's do the tracing of our sum. Okay, I'm gonna flip this. So let's do sum, it's a little shorter to write, of, let's do 5. I'm trying to do a good number. We have a lot of examples, but I don't want to get too big. Okay, so again, 5 doesn't equal 0, so I'm not going to worry about that. So now I'm going to return 5, and I'm going to add to it the the method for 4. Okay, so now I got to figure out what 4 will be. So again, I'm going to come down here and I'm going to get 4 plus the method with n minus 1 with 3. Okay, now I don't know what 3 is going to be. So sum of 3 should be 3 plus sum of 2. And again, don't know what sum of 2 is, but it should be 2 plus the sum of 1. So sum of 1 should be 1 plus the sum of 0. Okay, sum of 0 is the only one I know. Once the number equals 0, it's going to equal 0. It's going to return a 0 because once num equals 0, I get 0. Okay, so sum of 0 equals 0. So this is really 1 plus 0. Okay, now sum of 1 is 1. So now this is going to be 2 plus 1, which is 3. Now sum of 2 now equals 3. So this up here will be 3 plus 3. Okay, sum of 3 now equals 6. So I'm going to go up here and do 4 plus 6, which is 10. And then sum of 4 now equals 10. So I'm going to get 5 plus 10 equals 15. And again, this is what ultimately prints. Okay, so this is the sum of 5, 4, 3, 2, 1, and 0. Okay, so again, we start from the top and we got to keep going lower and lower and lower and lower until we get to that base case so we know what the value is so we can start building back up to what our original call was. Okay, so sometimes all we're doing is adding numbers, and in the other case we were actually tacking on to a string. Okay, so there's a couple different things you can do. All right, some of the other ones we did in class, we traced a couple more of these recursive methods. Okay, there's 5 in here. I'll probably just do a couple. Okay, so I gave them funny names like yellow, so you didn't know what was going on. So if our number is greater than 10, it will return 1, and then it'll run the recursive method again. Okay, so as soon as my number becomes less than 10, it's just going to return a 1, and then we'll be able to bounce back and see what happens. Okay, so we're going to run yellow 9876. Okay, so 9876 is definitely greater than 10, so I'm going to return 1 plus yellow. Now I got to take 976 and divide it by 10, so that's going to give me 987. Okay, I'm not going to do the else. Now I got to come back up. What is yellow 987? Okay, so that's also greater than 10, so I'm going to do 1 plus yellow of 987 divided by 10, which is 98. Okay, don't know what yellow 98 is. So let's figure that out. Still greater than 10. So I'm going to do 1 plus yellow. 98 divided by 10, that's just 9. So let's see, yellow 9. 9 is not greater than 10. So I can't do that one. So I'm going to do this one. So yellow 9 equals 1. All right. So now I can backtrack. Now my recursion is ended. Let's backtrack to see what my output is. So if yellow 9 is 1, this is really 1 plus 1, which is 2. Okay. Yellow 98 is 2. So 1 plus 2 is 3. And then yellow 987 is 3. So this is 1 plus 3, which is 4. Okay. So that is my output. So I'm going to speculate without doing another one that I believe this yellow method counts the number of digits in a number. Okay, and I should probably do a couple more traces just to double check, but that's gonna be my my guess. Counts the number of digits. Okay. All right, so that's one tracing. All right, let's do. All right, let's do this one. Let's do this one because this has a compound inequality here in my base case, in my if. Okay. Now this one, it looks like I'm gonna run the method and then print out the number. Okay. So red 5. Let's see. Red 5. 5 looks like it's between 1 and 8. So I'm gonna do red of 4, and then I gotta print. I'm gonna need that number 5. I'm gonna need my num. Okay. So what's red 4? So red 4, again, 4 is between 1 and 8. So I'm going to run red 3, but I'm going to print out my number 4. So what's red 3? Well, red 3, it's just going to run red 2 and then print out my 3. Red 2 is going to run red 1, right? And then print out my 2. 2 still between 1 and 8. Red 1, okay, 1 still between 1 and 8, inclusive. So I'm going to get red 0 and 1, and then I get down to red 0. Well, it doesn't match that, so nothing's going to happen at red 0. Okay, nothing's going to print out. So nothing prints out with the red 0, but I still get a 1 that's going to print. Okay, so now red 1 will print a 1, and then I'll get a 2. Okay, red 2, excuse me, will print the 1, 2, and then I'll get a 3 at the end of it. Red 3 will print the 1, 2, 3, and then I'll tack a 4 on the end of it. And then red 4 gives me 1, 2, 3, 4, and I'll tack the 5 onto the end of it. Okay, so again, this is my ultimate output. So let's see, what is that doing? It looks like it's just printing all the numbers between 1 and num, as long as num is between 1 and 8. Okay, so this prints numbers between 1 and num, but num has to be between 1 and 8. Okay? All right, let's do one more in this video. I'm trying to think of what's a fun one. Let's do this one. This one's fun. Okay, so we have our blue method here. And I like this because we got to do a little action down here, okay? All right, so we're going to trace blue 648. So we're going to put 648 in there. 648 is not less than 10, so we're not done. So we're going to come in here and it looks like we have to create some variables. So A is going to be 648 divided by 10, which is 64. B is going to be 648 modulo 10, so we know that's going to give our remainder of 8. So now we're going to run blue of 64 plus 8, which is blue of 72. Okay, so now we got to figure out what's blue of 72. Okay, so 72 is not less than 10, so forget that. So let's come over here and create our new A, which of course is 7. 72 divided by 10 is 7. B, 72 modulo 10 is going to give us a remainder of 2. So we're going to get blue of 7 plus 2, or blue of 9. Okay, so now we got to figure out what's blue of 9. Okay, 9 is less than 10. So it's actually just going to return the 9. Okay, so blue of 9 equals 9. So that's going to equal 9. And that also equals 72. So that's also going to equal 9. So this method will print out 9. Okay, now I'm not really sure mathematically what the connection is here. Okay, we were talking about that in class, but at least we learned how to trace our method, our recursive method, and we know what our output is. Okay. Okay, so hopefully this was helpful. I know it seems kind of a lot of work to write these out, but it's nice to kind of, organize yourself to be able to follow what it's looking for in each step of the recursion. Okay, so anyway, like I said, I hope this was helpful, and there are some more on this worksheet if you want to try them, and I've already posted the answers. So have fun with it. And again, don't worry about having to write recursion, but you do have to be able to trace it and understand what the output is. Okay, all right, hope that was helpful. See you next time.